Welcome to Mr. Garofolo's podcast. In today's episode, we are looking at creating quadratic equations for geometry problems. Today, I'd like to start by looking at example 5. In this question, we're given information about two squares. We're told that the larger of two squares has a side length 1 foot greater than that of the side of a smaller side of square x. The combined area of the two squares is 113 square feet. Find the length of the side of the smaller square. So what's nice about this problem is that they've defined the variable for us already. They've told us that the side of the smaller square is going to be represented as x. So I would advise drawing a picture, two squares, smaller square, larger square, labeling the smaller square with the side length of x, going back into your problem and finding that the larger has a side length 1 foot greater than the smaller square. We can define that relationship by adding 1 to the original side length. So our binomial side length for the larger square would be x plus 1. They go on to tell us that the combined area, so that's important, not just the area of one of these, but the area of both of them. So I'm going to use some subscripts here. I'm going to say area 1 for this square plus area 2, so a sub 2 for this square, must equal 113 square feet. So really the main driver behind this problem is what expressions can we use to represent the areas of these two squares? Remember, the area of a square can be found by multiplying side times side. And since all four sides of a square are congruent, side times side for this square would be x squared. So we would get x squared plus, and here we have a binomial. Throw some parentheses around that binomial. And once again, all sides are congruent, so we would have x plus 1 squared. And that would represent the area of the larger square. So here's our quadratic. X squared plus x plus 1 squared is equal to 113. We'll need to expand this binomial. Remember, the square of a binomial, square the first term, square the second term, multiply the two terms and double them. So the expanded form would look like this. X squared plus 2x plus 1. Now we can combine our like terms. We have 2x squared plus 2x and subtract 113 from both sides to get this in standard form. We're left with 2x squared plus 2x minus 112 equals 0. Now we can look to factor. Remember, we always want to look for the GCF first, and as I look at this problem, I see that there's a GCF of 2. That would leave us with x squared plus x minus 56 inside the parentheses. I think from here you should be able to take this one. Remember, you're going to end up getting two solutions. If one of them is negative, reject the solution because we're talking about finding lengths of a square, which wouldn't apply in this situation. Let's jump ahead a little bit. Let's also look at number 6 in your homework. Here we're told Olivia's walk-in closet is 8 feet by 10 feet. How many feet would need to be added to each side in order to increase her closet space by 88 square feet? So we might want to start by drawing a picture. Okay, so here's a rough picture of her closet, 8 feet by 10 feet. So right off the bat, we know something about the size of this closet. If it's 8 feet by 10 feet, then its area is 80 square feet, or 80 feet squared. But she wants to expand this closet. She wants to expand it so that she could increase her total space by 88. Well, if she already has 80 square feet and she wants to increase it by 88, that means the new area will be the sum of those two values. She has 80 square feet. She wants to increase it by 88. The new total area will be 168 square feet. We're going to want to hold on to that for a little later. Let's go back into some other features of this problem. We have to think about what we're asked to find, which is in the second sentence here. How many feet would be needed to add to each side? So we're going to let x equal the number of feet added to each side. To each side. So imagine us expanding this rectangular closet out in both directions, and it becomes larger. So not the greatest drawing in the world, a freehand one there, but essentially we're asked to find what is this amount in terms of the expansion. How much would she need to add? Well, that's represented as x. We could have x plus the original 8 feet times x plus the original 10 feet on this side. And remember that new area we found earlier? We're going to use that now. That new area will be 168. If we multiply binomials here, we'll get x squared plus 18x plus 80 equal to 168. In standard form, this would become x squared plus 18x minus 88 is equal to 0. All right, I'm going to stop here. Good luck with the rest of this one. I'll see you in class.